Hi guys, this topic is a topic that's going to come up a lot in your labs and your free response questions. And it's one of those that in years past, a lot of students really struggled with the concept. And so I want to introduce it to you guys early on so you can see it, so you can know where this tutorial is. And when we do come across it in labs or homework or free response questions, you guys will be prepared and it's not going to be really overwhelming. So it's not necessarily something that is in chapter 2, but it is a topic that's going to come up really frequently. And so I want you guys to be prepared for it. So here's the situation, and this is a lab that you guys could be asked to do. And so I want you guys to know this would be like a real life data set that a student collected. And the student is looking to find the acceleration due to gravity. Now, you should know, or you will be very comfortable with this number. You should be comfortable with the idea that the acceleration due to gravity on Earth is 9.8 meters per second per second. A lot of times in AP Physics, we'll round that out to 10 just for computation purposes. But that's the number they're trying to find. So even though it's known, we're trying to create an experiment that you could find that value from. And so what the student did is they took a ball and they dropped it from various heights. So they've listed the heights that they dropped it from. And they just recorded how long it took for the ball to hit the ground. And now the problem is they need to make sense of this data. And so the first thing I did is I went to Desmos, and that's something that you guys will learn to be comfortable with as well. And I plugged in the data and got this graph. Okay, now I went a little bit backwards. I put the height in for my y, the time, or the height in for x, time in for y. We may switch that around a little later, and we'll talk about that. So I have this column is x, this column is y, and it gave me this graph. Now, that's really cool that I have a graph, but I know that the purpose of this lab is to figure out the acceleration due to gravity. And although I collected great data, or the student did, and I have a really pretty looking graph, I'm not necessarily sure how to find gravity. And so that's what we're going to talk about next. Okay. You always want to think about when you're analyzing a set of data, what are you looking for? And then you're going to think about what do you actually know? Okay, so we're looking for gravity. So we're hoping to get some number at some point in time of 9.8 meters per second per second. But now we need to think about, like, what do we actually know? And so we're here. And so here's my list. We have height, so that's something we know. We have time. In the problem, it said, okay, the boy dropped the ball. So if he's dropping the ball, I'm assuming its initial velocity is 0. It's not moving. Height of 0, he said he dropped the ball from rest. And on the data table, you could see initial time and height was 0. No idea what our final velocity was. And we know gravity is what we're trying to figure out. So once we kind of go through everything that we're dealing with, then we go and we look at the equations that we actually have access to, okay? So I pulled these from your equation sheet, and that's the same equation sheet that's in your course materials, and that's the one you have for every test, every quiz, and that's the one you get on the AP exam. So I have these 3 equations. You guys will have to wrap your head around the idea that X does not stand for X, as in like what we're plugging in for X, but X stands for position. And so here, like, this is my final velocity, my initial velocity, acceleration, and time. But then in this one, final position, initial position. Okay. And so we're looking at these 3 equations, and we're trying to pick one out based off of this information. Okay. So I kind of narrowed it down. We know the final position. We know the initial position was 0, and we know the initial velocity was 0. Okay, so I'm going to go with that middle equation. I'm not going to do this one because I don't know my final velocity. So I don't know this part of the equation, so I'm going to cancel it out. The A should be the only thing that you guys are looking for because acceleration is gravity. Okay, in this instance, because the ball was in free fall, the acceleration the ball has will be the acceleration due to gravity. So that should be the only unknown. So if I don't know this, this equation is out. Down here, I don't know my final velocity, so this equation is out. But the middle equation, I know I can cancel out this and this because the initial height and velocity is 0. And so what I'm really dealing with is this equation. But when I take out what's 0, I have x, which is my height, is 1/2 at squared. My data table has height and time. The only thing my data table doesn't have is acceleration due to gravity. And so that's how we're going to narrow down this equation. But once we narrow down the equation, then we have to think, like, what does this mean to linearize a set of data? So I'm going to go over here. Actually, I'm going to flip back a little bit. When I linearize a set of data, I'm creating a data set that instead of being a curve is a straight line. And the only reason why we want to get that straight line is because a straight line is something we can easily find the slope of. Okay, so this is where it gets kind of complicated. So make sure you're following along. We know our height, and we're going to make our height our y. We are looking for this, and we're going to make our x this whole quantity right here. I don't even think I'm recording. Oh, yes, I am. Okay. I want that little box right here. Okay. Sorry, guys. Here. Taking a break with me. Oops. Okay. I want this. I want to go back. Okay. So we are here. So I'm going to... This is my height. Okay. And then this whole quantity right here, this is what I'm putting in for x. So instead of having a data table labeled x and y, like time and height, my x is really going to be 0.5 t squared. Because now I have something, if I think about it, like, okay, I know y equals x plus b, but our y-intercept should be 0. So we just kind of scribble out the plus b. Okay, so this is slope-intercept form. So what I did is I just made my acceleration due to gravity my slope. And so I took my time right here and I multiplied it. Well, I took my time. First, I squared it, and then I multiplied it by 0.5. And that's where this number came from. So I had to manipulate the data to get this. Height, I didn't have to do anything because height is my x. So that's something I don't have to do anything to. But when what I plug in for my x is going to be the 1/2 t squared, because then when I look at the slope of that line, the slope is going to represent the acceleration due to gravity. And so now if I flip over in the slide, so now if you look at this, I went into Desmos and I plugged in my height for my y, and I put the 1/2 time squared in for x. And I got this set of data. Okay, all these little purple points right over here. All right, I got this set of data, and then I used the program to help me find my slope and my y-intercept. It's going to give me a y-intercept because we collected the data. Well, we didn't, but some kid collected this data, and it's not 100% perfect. Okay, so maybe he was a little off in the timing. The fact that this is really close to 0 is a really great thing, okay, because we know we shouldn't have a y-intercept. But now if you look at the slope, it's 10.35. Now we know our slope should be gravity. and gravity is 9.8. So the fact that this is 10.35 means we're doing a pretty okay job here. Okay, so we didn't get 12 or 15, we got a number relatively close to 9.8. And as I stated before, a lot of times we round acceleration to 10 anyway. Well, acceleration due to gravity to 10 anyway. And so here's our original equation, slope-intercept form. So we always want to make some sort of linear graph. This is what we decided we were plotting. Height equals 1/2 a times time squared. We made the note because this is in free fall. Acceleration is gravity. And then we experimentally found out that gravity was the slope of our line, which was 10.35. So here we would be able to make the statement from our data, or from this kid's data, that gravity is 10.35 meters per second per second. Okay, and it's not perfect. That is absolutely okay. When you collect data, it is not going to be perfect. But we had to go through this whole process, which seems really long now, but eventually it will seem a little bit less long. It's still tedious, but eventually it hopefully will become second nature to you guys. Be like, okay, yeah, I want this to be my slope, so this is how I have to manipulate that data. So thanks for watching. Sorry for the little blip in the middle of trying to find the screen. But anyway, yep, happy watching.